Hello students, my name is Professor Muhammad Asim and we are doing AdMath. AdMath for IGCSE students which have syllabus code 0606 and for CIE O level students which have syllabus code 4037. So both kind of students can get equal benefit from this course. Students, in last lecture we finished exercise 10.1 from chapter number 10. Name, permutations and combinations. The topic of exercise 10.1 was factorial notations. We did all about factorial from exercise 10.1. Today we are going to start another topic 10.2. You can see on your screen arrangements. But before I start this topic, I would suggest all those students who are watching my lecture first time, kindly go to my playlist. There is a folder, name is AdMath. Watch previous lectures of this chapter. After watching previous lecture, definitely you will have good command on this topic. Okay, let's start this topic. Arrangements. Students, I am reading this class discussion topic. These books are arranged in the order BROG, blue, red, orange, green. The books could be arranged in the order OGBR. Find the number of different ways that the 4 books can be arranged in a line. So there are so many ways to arrange. What is the method? You can see. Suppose we have 3 letters A, B and C. I am reading this line. So how many ways to arrange these 3 letters? There are possible arrangements. One can be ABC, then ACB, then BAC, then BCA, then CAB and then CBA. So there are 6 different arrangements, but this is a very lengthy way to write the arrangements. If we have 5 or 6 letters, then it will be impossible to make arrangement in this way. So we will go to method 2. This is method 2. Consider filling 3 spaces. So you have 3 letters A, B and C. So for first letter, in first empty square we have 3 choices, and after filling first square, for remaining 2 letters we will have 2 choices in second boxes, and after filling second box we have only 1 choice for the third one and last. So we have 3 into 2 into 1. So we have 6 ways to 6 ways or 6 possible arrangement to write 3 letters A, B and C. And you know, 3 into 2 into 1 means 3 factorial. This is what we done in exercise 10.1, the meaning of factorial. So after giving these examples, we are able to start exercise 10.2. Question number 1. Find the number of different arrangements if 4 people sitting in a bench. So 4 people means the first one we have 4 choices, the second one we have 3 choices, the third one we have 2 choices and the fourth one we have 1 choice. Or you may write directly, not necessary to write 4 into 3 into 1, you can write 4 factorial and you can use your scientific calculator, you will get 24. So there are 24 arrangement for these 4 peoples. Part B, 7 different books on a shelf. So obviously the answer should be 7 factorial. So use your calculator to find the answer of 7 factorial, which is 5040. This is our answer. Question number 1. Move to question number 2. Find the number of different arrangements of letters in each of the following. Part A. Tiger. T I G E R. Tiger. So how many letters in the word tiger? 5. So we can write 5 factorial, and the answer of 5 factorial is 120. Very easy. Part B. Olympics. How many letters in Olympics? Count 1, 2, 3, 4, 5, 6, 7, 8. So the answer should be 8 factorial. What is the answer of 8 factorial? Is 40320. 40320. This is the answer of part B. Move to part C. Paintbrush. How many letters in paintbrush? Count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there should be 10 arrangements. What is the answer of 10 factorial? 3, 6, 2, 8, 8, 00. This is the answer of part C. So very easy. Move to question number 2. Move to question number 3. What is question number 3? Question number 3 is find the number of different 4-digit numbers that can be formed using the digits. Part A. 3, 5, 7, 8. Without repetition. It means no digit will repeat. So how many arrangement could be made? Obviously 1, 2, 3, 4. 4 factorial, or you can write 24, because the answer of 4 factorial is 24. Part B. Part B is more interesting. How many of these 4 digits numbers are even? Are even. Very easy. How to make even number from these 4 digits? How many even numbers in these 4 numbers? Only one, that is 8. So we will fix 8 in last position. The remaining letters 3, 5, 7. So if we fixed a number in any position, we will not count that number. And you know, even number is always we say the number is even if the last place is even number. So 3, 5, 7 can be arranged in 3 factorial multiply by 8 is fixed. You can write 1 or not necessary to write 1. 3 factorial is 6. So when we fix the number, we will not count that number. So the only answer is 6, or only answer is 3 factorial. Part 2. Greater than 8000. How can we make a number which is greater than 8000? We should fix this 8 in first position, because if we put 8 in first position and remaining 3 letters in any position, the number should be 8000, greater than 8000. So remaining numbers are 3, 5, 7. These 3, 5, 7 can be arranged in 3 factorial form. Therefore, the answer of this is also 6. So these are this is the answer of part 2, and very easy question, very interesting. So you must have the concept of fixing the numbers. Move to question number 4. Now more interesting questions are starting. Question number 4. A shelf hold 7 different books. So we have 7 books total. 4 of the books are cookery books, and 3 of them are history. So 3 books are history books. Part A. Find the number of ways the books can be arranged if there are no restrictions. No restriction means you can put any book in any place. So the simple answer is 7 factorial. So what is the answer of 7 factorial? Is 5040. Now move to part B. This is more interesting. Find the number of ways the books can be arranged if the 4 cookery books are kept together. What does it mean? 4 cookery books. Four cookery books are kept together, and remaining 3 books history books. So what should be the answer? See this. These 4 cookery books makes one block. So these 3 history books along with one block makes 4 factorial. Multiply by these 4 cookery books also can arrange itself. So these 4 cookery books arrangement is 4 factorial. I repeat again. 3 books history books plus 1 block is 4 factorial. Multiply by 4 cookery books itself arrangement is 4 factorial. Therefore the final answer you can find from the calculator is 576. So very easy question and very important also. Move to question number 5. Five digits number are to be formed using 2, 3, 4, 5, 6. Each digits may only be used once in any number. So there is no repetition. Find how many different 5-digit number can be formed. So first part is very easy, that is 5 factorial, and the answer of 5 factorial is 120. Now part B, a very important part. How many of these 5 digits number are even? So we have 5 digits and we have to make the number is even. So we have 3 digits are even, that is 2, 4 and 6. So we have to put one number out of these 3 numbers, in the last place. So this is 3, multiply by how many remaining numbers? Count this. After these three we have 3 and 5. We have 3 and 5. Kindly wait. Now, how many digits are remaining? One is 3 and one is 5, and we have put it one digit out of these three digits. So total 3, 5, and from this two digits are 4 arrangement, that is 4 factorial. So 3 multiplied by 4 factorial is 72. I repeat again. For making an even number, we have to put 2, 4, 6, 2 or 4 or 6 in last place. So there are three possible ways to put the digits in last place. So 3 multiplied by, so if we put one digit from these three, so remaining are two digits, and these 2 plus 3 and 5, 2 is 4, so 2 plus 2 is 4, so 3 multiplied by 4 factorial, that is 72 is the answer. So hope you understand. Now move to next part. So these are very easy parts and very important. Greater than 40,000. Greater than 40,000. So for greater than 40,000, first place must be 4 or 5 or 6. So there are three possible arrangements for first place. Multiply by, so if we put 3 if we put one digit from these 3, 4, 5 or 6 in first place, then remaining these two digits along with a smaller digit, that is 2 and 3. 2 and 3, there are two digits, so 2 plus 2 is 4, so 2 multiplied by 4 factorial is the final answer, that is 72. So part C answer is also 72. Part D, very very important part. Part D is greater than, even and greater than 40,000. So for this part we have to make three choices. The first choice is, if we put 4 in first place, because we have to make the number greater than 40,000. So if we put 4 in first place, so and then last place must be 2 or 6, because we have to make the number greater than 40,000 and also even. So for last place we have two choices. So 2 multiply by 4 is fixed. For these two digits, 1 is from two digits, that is 1 is remaining, plus after fixing these 3 we have two from 1 and we have two digits are left, that is 3 and 5. So 3 and 5 2, therefore 1 plus 2 is 3 factorial. So this is first choice, 2 multiplied by 3 factorial. Or now second choice is, if we fix 5 in first place, so definitely we have to fix 2 or 4 or 6 in the last place. So these are three choices, 3 multiply by, so remaining 2 along with Kindly wait. 5 is fixed, and 2 from here left, and 1 from here, that is 3. So 3 means one letter. 2 plus 1 is 3 factorial. I am repeating again. The second choice should be, because we have to make the number greater than 40,000 and even. So first is fixed, that is 5. The last one is 2 or 4 or 6. So after fixing 1 from 3, we have 3 choice for last position. So we have to write 3 multiply by. After fixing last, we will have 2 letters remaining, and the 1 letter, that is 3, also make arrangement 2 plus 1 3. So 3 into 3 factorial is the answer. The next choice is we have to put 6 in the first position, and obviously 2 or 4 in the last position. So for last position we have 2 choices along with 1 letter from this and 2 letters remaining. So 2 plus 1 is 3, so 3 factorial. So our final answer is 2 multiplied by 3 factorial plus 3 multiplied by 3 factorial plus 2 multiplied by 3 factorial. And now use your calculator, you will get the answer 42. This is very important question according to examination point of view. So kindly do practice and listen carefully what I am saying. Next question, number 6. Three girls and 2 boys are to be seated in a row. G1, G2, G3 represent 3 girls. B1, B2 represent 2 boys. So total we have 1, 2, 3, 4, 5. Total 5 people. 3 girls and 2 boys. Find the number of different ways that this can be done if the girls and boys sit alternatively. So alternatively means we have 3 girls, so we have to write 3 factorial, multiply by 2 boys, we have 2 factorial. So 3 factorial multiply by 2 factorial, answer is 12. So hope you understand. This is you can check by manually by putting G1, B1, G2, B2, G3, B3 and so on. So alternatively. Now move to part B. A girl sits at each end of the row. It means if we fix for example G1 in first place and G3 in the last place, for example. So we have G2, B1, B2. I repeat again this part. A girl sits at each end of the row. So for this is 3, G2, B1, B2. G2, B1, B2 means 3 factorial. Multiply by. Now this is very important. For first position, we have G1 and last position we have G3. For second choice we have G2 and G3. So we have three girls, and these three girls, out of these three girls, two girls can be arranged first and last positions. So we can write is 3p2. 3p2 or 3 factorial both have same meaning. So we have answer is 36. I repeat again, we have to take two girls out of three girls to arrange in first and last position, G1 G3 or G2 G3 or G2 G1 or G3 G1. So we have six choices for three girls in first and last position. Part C. The girls sit together and the boys sit together. This is very important part. So if the girls sits first, it is 3 factorial multiplied by boys 2 factorial, or if boys sits first, it is 2 factorial. If girls sit at second position, so it is 3 factorial. So you can write 2 into 3 factorial into 2 factorial. The answer is 24. You can check from your calculator. So student, this is question number 6. Hope you enjoy this question. Move to question number 7. Part A. Find the number of different arrangements of the letters in the word orange. So first part is very easy. How many words? How many letters? 1, 2, 3, 4, 5, 6. So answer should be 6 factorial, and 6 factorial answer is 720. Part B. Find the number of these arrangements that begins with the letter O. So with the letter O means we have to fix O in first place. So now we will not count O. So remaining letters are 5. So 5 factorial. The answer is 120. I hope you understand. Part C. Part C is have the letters O at one end and the letter E at the other end. So if we fix O in first position and E in last position, or E in first, O in last position. So for this, O and E are fixed, so we have to write 4 factorial, and E and O are fixed, so we have to write 4 factorial. So 4 factorial plus 4 factorial is 48. You can check the answer from your book. So this is question number 7. Very important, very interesting according to examination point of view. Move to question number 8. Part A. Find the number of different 6-digit numbers which can be made using the digits 0, 1, 2, 3, 4, 5. Without repetition, assume that a number cannot begin with 0. So we have to make arrangements, but the numbers cannot begin from 0. So for first place, we can put 1 or 2 or 3 or 4 or 5, and remaining place we can put 0, but first place 0 cannot be allowed. So for first place we have 5 positions, multiply by how many after first digit, how many remainings out of these 6 digits? we have 5 letters remaining, so it is 5 factorial. So 5 into 5 factorial is 600. Now part B is very important. How many of the 6 digits number in part A are even? In part A are even. So we have made in part A there are 600 arrangements. So in this arrangement even and odd both are present, but we have to give the answer only even arrangements. How it is possible? So I will first find all odd arrangements and then subtract from 600, we will get the final answer. Okay, now for odd arrangements, if we put because we have to make the odd number, so if we put for example, kindly wait, if we put in first place 1 or 3 or 5 in first place, so for first place we have 3 choices. Okay, so after placing 1, 3 or 5, after placing first we have 3 choices. Now we cannot put 0 in last place, otherwise the letter will be counted even. So we have to make the last choice. For last place we have how many choice? 2, sorry, for last place we will not put 0. After placing 1 digit in first position out of 3, we have remaining 2, we have remaining 5, but 0 will not allowed, therefore only 4 choices which is put in last place, so it is 3 into 4. Now after 4 we have set it 2 digits in first position out of 3, because we have to make the odd arrangements, and without 0 we will have 5 remaining. So we have without 0 we will have 5 remaining, first is fixed, therefore only 4 out of we have only 4 choices in last position. Now how many remaining? Only 4 letters remaining, which can be put it in middle places, therefore it is 4 factorial. So the final answer is 288. Final is 288, but this is not our required answer. We have to make even 6 digits. So for even we have to subtract 600, the answer of part A, minus 288, which is equals to 312. So hope you understand this question. This part is very important. Move to last question. Six girls and 2 boys are to be seated in a row. We have 6 girls and we have 2 boys are to be seated in a row. Find the number of ways that this can be done if 2 boys must have exactly 4 girls seated between them. So for example, this is boy 1 and this is boy 2 and out of 6 girls we have to take 4 girls in middle one. Now remaining 2 girls can be seated out of after second boys and after first boys, so no restriction for remaining 2 girls. So for these B1 and B2, 2 boys, we have 2 choices, multiply by, because B1 can be right first and B2 second, or B2 first, B1 second. Now for 4 girls we have to write 4 factorial. So after 4 girls, how many girls are remaining? 2 girls. And for this B1, 4 girls, B2, we have to make one block. So 2 plus 1 is 3. So we have to write 3 factorial. The answer is 288. Very easy question and very important according to examination point of view. I repeat again, we have to set 4 girls between 2 boys. So for boys we have 2 arrangements, B1 first, B2 last, or B2 first, B1 last. So 2 multiply by 4 girls means 4 factorial, multiply by 2 girls and 4 girls and 1 boy and 2 boys make 1 block, and 2 remaining girls. So 2 plus 1 is 3, 3 factorial. So 2 into 4 factorial into 3 factorial is 288. So student, this is our today's class where we finished all questions of exercise 10.2. Very very important exercise according to examination point of view. Kindly do practice more and more and more. I will definitely help you if you have any problem in any question. What next? The next exercise is permutations. So permutations is another name of arrangements. So almost the same question just like exercise 10.2, but more important questions in exercise 10.3 as compared to exercise 10.2. Don't worry, I will do each and every questions. How many questions? Question number 9. So student, this is our today's class. Kindly do subscribe my channel, and whenever you subscribe, don't forget to press the bell icon button so that when I upload my videos you will get the notifications. Kindly share my videos, my lectures, as many as you can. Okay students, good luck for next lecture.